So we're here in annuities, and the idea, remember, is it's a kind of account, but it's not like when we first saw these kinds of accounts and compounding, where you deposit once and you let the money and you let the account do what it does, compound on its own. With something like an annuity, as we can see here, you're putting money into the account on a regular basis. And then it's also earning interest. So in other words, we don't have just one deposit here. We have many, many deposits. I mean, this is in the notes, so I'm going to not go through it that thoroughly. This slide, I mean. But let's say we have this example, okay? So let's say that, through a bank or investment or whatever, or even a retirement account, well, we'll get to that. Let's say we're depositing $100, $100 each month into a bank account. And let's say the account is earning 6% interest compounded monthly. So we have this kind of account. Now notice though, we're not just depositing $100 once and letting the money sit there. We're depositing it each month. Okay? As you can see, we're not just having one deposit. So we want to answer these questions. How much are you going to have in that account 15 years later? How much total money are you putting in? And what's the total interest you earn? Okay, well, so to solve this question, we're going to use the annuity formula. I mean, you technically could use that TVM solver. Again, let's just stick with the formula for now. I mean, theoretically, I think the formula is a little bit easier, but the calculation can be not too involved, but it can be annoying, so to say. But again, this is our formula, and this is just a notation for it. So, we've seen this before. So A is the balance after T years. T is the number of years, of course. PMT, remember, is how much our deposit is, regular deposit, the amount you're putting in each month, each year, whatever. R is the interest rate as a decimal. N is how many times it's being compounded in a year. And again, this is the convention we're following. Okay? That if they don't tell you explicitly what the compounding frequency is, we just assume it's the same. The number of compounding period, the number of times it's compounded a year is the same as deposits per year. Although here it tells us that it's being compounded once a month. And we're also depositing once a month. But if for some reason they didn't tell us how often it was compounded, we would assume it's being compounded monthly because we're making monthly deposits. So now we're going to use this formula. Okay. So here what I'm doing is we have to figure out what the variables are. So notice we want to know the total balance 15 years later. Okay. Okay, so A is basically what we're looking for. So that's the unknown. PMT is the regular deposit, okay? How much you're putting into the account each month. That's $100. The interest rate, that's what R is, but you have to express it as a decimal. That's what I'm doing here, 0.06. N is how many times we're compounding it in a year. It's being compounded monthly, right? It's being compounded monthly here, so we get 12. Monthly, 12 times a year then, 12 months a year. And how many years is it in there? 15 years. So now we're going to put all this into the formula, like so. And this we have to calculate. Now to calculate this, you really want to handle it one piece at a time. So you would do this quotient first. Well, actually, I'll show you that. Okay. But this is the formula we're going to deal with. Again, it's in the notes, so I don't want to go too fast, but you don't have to copy it down. But we have to figure out what this thing is. So notice the way I'm calculating it is this. I'm basically proceeding by order of operations. I'm working on this parentheses first, right? That's 1 plus 0.005. So you're working from the innermost outward, if that makes sense. So we have 1 plus 0.005. And of course, that's just 1.005, right? So that's the innermost thing first. Then we handle the exponent. 15 times 12 is 180, right? We're doing parentheses first, the innermost one first. Now, what is 1.005 to the 180 minus 1? Well, you know, that's not so easy to calculate in your head. What's nice is we don't have to. We have calculators. But again, let me say it again. We're working in the innermost first, as you can see. Then, right, we're working with the innermost first. So we did the quotient. And this parentheses here we handle, so we just get 1.005. Then we handle the exponent, as you can see. Now we would have to calculate this power here first. So I reproduced it over here. And this here, 1.005 to the 180, you know, in a calculator, you would get this. I would use as many decimal points as you can. Okay, I mean, in the end, you're going to want to round to 2 decimal places. But the more you use, the more accurate your answer is. So we have this here, as you can see. Minus 1, right? This here was the 1.005 to the 180. We're subtracting 1. And we get this. Now we multiply the top. The bottom, there's not much more you can do. You just leave it alone. And this quotient we get, which is equal to this. So this is how much will be in the account in 15 years. So if I rounded to 2, so what I did, let me go back. I rounded this to 2 decimal places. So after the 7, we have a 1, right? So the 7 stays where it is, and we get this. So in 15 years, okay, what we get is this. Now notice, this is how much will be in the account, not only from our deposits, but also from the interest earned. You know, the money the money that's in there, right? It's going to get compounded. So there's going to be interest building. But for part B, remember, we wanted to know, let me go back. We wanted to know how much total money are we putting into the account. So in other words, we deposit $100 each month, right? And this is going on for 15 years. What they're asking is, in total, how much are we putting in to the account in total? So again, we do $100 per month, and this is for 15 years. Okay, so we have to calculate. So we're going to use this. It's $100 per month, right? We know there are 12 months in a year. And there are 15 years. So basically we multiply. If you remember from the very beginning of the course, I think it was the 2nd chapter, this is actually what they call that factor label method. You know, you multiply and the units cancel. That's actually what's happening here. But either way, you just multiply the numbers and you end up with $18,000. So the total money we're putting in is $18,000, okay? But what about, that's not the full account though, right? Well, if this is not the total balance, then what's left over? The interest. Remember, we're putting money in, but the money in there is earning interest. How do we get that? Well, it's whatever else is in there. The amount left, in other words. So in other words, if we take the balance, right, and we subtract off how much we put in there, the amount that's still there was what interest gave us. And that's what this is saying. This is the amount that interest gave us.